on custom service. Okay, so cool, we're live. Now, I don't want to go get the microphone today, so if you ask a question, you want it to be audible, we'll have to shout or turn this around. Oh, even with the
microphone, with the student is
yeah. All right, well, that's good to know, I guess. It's too bad. All right, so I guess we can get started in like 1 minute, or it's not quite 5:30, but do people know that it's, Jesse said it was in here, right?
Yeah.
In the channel. Okay. Six more, 7 more. You know, is Elizabeth? Do you think is Elizabeth still out? Has anyone heard from her?
I haven't talked to her. I asked her, but it's something about all of you for work or something.
Okay. Okay. Oh, thank you. I sent them to Alice, but not.
And it was a good thing that I did what I did today because I did forget a couple of things that I had forgotten.
Okay. Those are the slides.
Mm-hmm.
I think we can get started. Today we have a guest speaker. This is my coworker, Charissa. We work on the same pod of desks and sometimes on the same stuff, but not often. I thank you very much, first of all, for like coming and talking to people, and go ahead.
Yeah, this is cool. So I took a very non-conventional route to becoming a software engineer, which is what my title is. But yeah, I just wanted, thanks for the invite, because like I want everybody to know that it's possible. You don't have to do like the degree, like it does happen. So
I don't have a degree either.
You don't?
Not in computers.
Okay. Yeah, so I'll just talk about like, my path and kind of what I do now, and, some tips, that I can maybe pass on. But I really, yeah, I learned the hard way. I did things the hard way for a while. But I graduated like high school, maybe 15 or so years ago. I tried the traditional college route. I didn't necessarily know that I liked programming, but I think the best thing that happened my first semester of college was programming 101. It was like C++ entry level, and I just happened to really like it. Like I just, I like math and algebra, and I was like, oh, this is not rocket science. Like this is cool. But like the traditional college route was not for me. I just wasn't very good at college. Like I could do some classes well, some classes not. And so I basically just bounced around to like 3 different colleges, focusing on programming, but just kind of not sure what I was going to do with it. I did land a gig. My first corporate gig without a degree was in programming, which I thought was great, but it turned out to be a very niche programming language. So I just pigeonholed myself basically, and it was like really mundane. It was if-else statements, and there was like no room for growth in the company. So I was like, this sucks, So I just, I was living down in Virginia at the time. I wanted to come back to New York. So I came back up here thinking that I could maybe find something else in tech, but this was 2008 and the economy was totally tanked. So there was like nothing anywhere in the country, especially not here in tech. So I kind of like bounced around for like a decade, doing like everything under the sun, bookkeeping. I did graphics for the newspaper. I was doing some web design for like friends, companies, and things like that. But mostly just odds and ends jobs, like lots of part-time jobs, and always had in my mind that I wanted to get back into programming. Hey, I'm just telling my story. I worked with Gus. And,
This is my coworker Charissa. She's the guest today.
yeah. So I ended up, a friend of mine needed like, he had a security company and he like needed a project done. I was like, well, I used to be a programmer, used to do programming. He's like, all right, well, tackle this. And it was as close as I'd been to like real, coding in like quite some time. And I was like, what am I doing anymore? Like, I just got to get back into this. So at the time, this is 2015, there was no program like this at the time in Syracuse. So I had to go somewhere else. So I had to live in Colorado. There's a program out there that's like a deep dive 10-month program into Ruby on Rails. So I took a huge risk and quit all my jobs and moved out there to like basically see if I could make a go of it or be homeless on the street. I didn't know at the time. The cool thing about it was like this whole new world of web development had opened up. Like I was like, oh, there's GitHub and there's Stack Overflow and everything's so accessible now. You can have any computer. Like when I was in college, you needed a special like compiler hardware. You couldn't just like any computer could just do it. So I was like, this is awesome, and build some things with Ruby on Rails. I didn't love Ruby on Rails, but I was making cool things. I was learning enough to just know that I was happy to be back in like the field of web design. So I came back I didn't want to stay in Colorado, came back here, after a year or so. And it was like, now what? I knew there was a couple of companies in Syracuse that I had tried to apply to, but they were looking for more of the traditional student route, like fresh out of college kind of thing. And so I was like, well, maybe I could get something in New York City and commute. And at the same time, I was seeing, if there was any meetups locally, and there was. So I, was nervous about it, didn't know what to expect, didn't know one single person in the programming or web development field in Syracuse. So I just, tried to find the space. It's like right down the street, the co-working space. I don't know if you guys have been
there. Yeah.
Yeah. Okay. Cool. So walked in there and. There's a little round table, and this guy, John Shanley, who we work with, also happened to be talking about they needed an intern at Density to walk around Syracuse with this like janky equipment, and it might involve some programming. I was like, so I don't know, that sounds awesome. Like I did some research on Density as well, and I was like, this company exists in Syracuse. This is it's a startup. It's been around for a while. They're doing something cool, and I was just like mind blown that this company even existed. So I knew I wanted to do something there, and I just learned what I could while it lasted, and didn't know if it was going to be long term or anything. But it's worked out, and I moved up from intern to associate software engineer, and now software engineer. Still have lots to learn, but. So basically what I do at Density is work with databases, which is what you guys are working on. And my experience in databases was very little. They were just simple databases. So I just recall I was taking basically queries of data. So have you talked about what Density does?
Yeah, not really. I don't know. Does it?
Well, basically, I mean, I could just do a quick one. I don't know how familiar, but so there's a API that we built, and it's basically we have organizations which have doorways or installations which have 3-minute videos associated with them. So this is the link: organizations to installations to captures, which are basically 3-minute videos, and captures have entrances and exits. So I had to get to the entrances and exits data, and I was like, piece, and just didn't know what I was doing. Gus was like, oh, rate organization, do a double underscore, rate installation, do a double underscore. And we get like all the annotated events that I was looking for. And I was like, are you kidding me? This is awesome. And also like, I'll never be able to do this. Like, that just seems like magic to me. I don't understand how that works, but now it's like second nature. Databases are really fun to work in. So, I mean, I think so. And what I like about it is you can just have huge, massive sets of data. It doesn't matter how much data you have. Like, if you know how to get to what you want through queries, I mean, it's very simple and you can do anything with it. But there is a lot to know. So like, I've been working with this database for like almost 2 years, and I'm just now getting to the point where I can like make more efficient queries and learning some tools for measuring how fast the queries are. So, you know, the good part is that you're constantly learning, and like the bad part is that you're constantly learning. Like, you can get good at something and then and it's like obsolete, and you're like, oh, now I have to learn this new thing. But I mean, I think that's cool. Like, I've had really boring jobs before and don't really want to go back to that. So, I mean, I guess that's it. I'm just gonna summarize it and like, you know, offer like some things I learned along the way to like, to kind of, if you have a non-conventional background, like, you know, what to do. And what I had done is built things that meant something to me. So build programs and applications that like mean something to you, because then you can talk about it easily. And people, that's what people want to see. Like, if you're interested and passionate about what you made, it's just so much easier to talk about things, and like you can show something to people that like, that I did this, you know, I made this and I can make more things. Networking is like the biggest piece of it. I think, you know, me meeting our coworker Don at that meetup, I would not be working here if it weren't for that. I'd be like, who knows, like commuting to New York City, maybe, you know, I don't even know. It just like, that's really what it's about, is getting out there and talking to people in the field because things just happen, and there's, you know, there's meetups here, there's this now, and there's ways to do it. It's not, you know, it's not just made up. Like, I did it. Always be humble, always learn as much as you can from anybody who knows as much or as more as you. Gus is the most amazing resource. He's like, not even, it doesn't matter how busy he is, he'll like take the time to like, you know, talk through something with me that I've been like kind of beating my head against for a while. And there's lots of people like that in Syracuse. I mean, that's why there's like programs like this. So, I mean, the reasons are out there, and just be humble and just ask and learn as much as you can. But I think the most important thing about this program is that like, you have to know what strength you're bringing to the table. Diversity is so important in a startup world. There's like homogenous startups that fail all the time because they're like solving the wrong problems. You know, it's like, we have like real life experience, and, you know, just, it's not just about cultural diversity, it's about like perspective diversity. So just know that like, you have a lot to offer the programming world, and that's kind of, I don't know, like the direction that software is going is really, it's really fun. So yeah, that's about it. Anybody? Yeah, please.
Questions?
Why did you leave Virginia? That's like my dream.
Really? Yeah, I lived on the beach on the Chesapeake Bay, so I ask myself that a lot as well. I guess, you know, part of it was family. I grew up here, so I wanted to come back and be back in that. But also, I mean, there wasn't anything very interesting happening in industry. You know, I had like this boring job, and I didn't see anything exciting happening down there. I don't know if it's still, maybe there's more of a tech presence there now, but I just like wasn't seeing much reason to stay. I mean, the weather's beautiful for sure, and cost of living, I think is a little bit better, but yeah, I actually really like it here. Like, there seems to be like progressive things happening, and I just want to be somewhere where people care about their community and want to, you know, make things better. Virginia, they're just happy. They don't need to make anything better. They're like fine with it. Right. They just go to the beach. Yeah. I mean, it was cool. No complaints, but yeah, just decided, I don't know. I've never been any place for very long, but I'm happy here now, so we'll see.
Any other questions?
So that's if she's an associate program, I'm pretty sure.
I think we have the same. You said you
I was
graduated.
associate,
Yeah.
but I'm just software. So technically we're the same title, but he's
I guess. I mean,
much better than me at a lot of things.
And you started as an intern?
Yeah, well, I mean, yeah, I started as an intern, but that didn't really make sense for very long. So I think like, pretty soon after I had started this intern, it was basically an internship. It was like, but then it became more contractual. And I think that's when I moved to associate programmer because it turned out that I could do more programming than walking around with the camera. I mean, both things were important, but I guess I showed that I could do.
yeah, and
build things.
I mean, we needed that before we had actual customers and like places where it was actually for real, which is, this is to develop the tools and the algorithm that's actually doing this counting. We needed like a bunch of data as if we had customers and they had actual products in the right place. So that's what you
So I
had to
literally
do.
walked around to like coffee shops and like, but like,
But like in real life.
but in real life, yeah, we had like simulated data that they were using, but I was begging local store owners to let me like set this thing up in their doorway. And from working at the coffee shop, that actually I knew a lot of people just from it's a small town, so I was able to kind of get my foot in the door. Like thinking I'm some spy or something because they had seen me before. So it worked out well for getting that first set of data, and we built this API that I work on now every day, starting with that data that I was collecting, which is really cool to build something from the ground up and have a piece of that, and then just like see it grow and what you can do with it, and also how you can mess it up and have to change it.
We did have to go out to certain restaurants a couple times over because you would come in and say, all right, they agreed to get some data, but everyone has to go here for lunch now.
Yeah.
So we're like, okay.
I forgot about that. Yeah.
Yeah.
Like,
Couple
get two
different
customers,
places,
I promise. And then I come back and be like, all right,
Yeah.
guys, I don't care if you brought your lunch. We're going to this place because they said I could capture data for their lunch period.
Yeah.
Yeah, it's fun. I mean, that's the other piece of it. I mean, make sure you look into places that you want to work with because I never thought I would enjoy a job as much as this, and it's about the people. It's about like the environment, like looking to hire people like me, and looking to just be different, think outside of the box. So, yeah, it's a great place to work.
Can you talk a little more about what you mean by database that you're managing? Is it more substantive where you're really understanding the data and studying it, about it, or more structural?
We're not trying to understand the data. We're trying to become more accurate. So we're building tools on the structure to make it more accurate. So, I mean, the hierarchy I gave you is very basic, and we're building things on top of that, like frames that we can send into deep learning. So each chapter has concept of frames, and it's like it's really what I'm doing is creating endpoints so that tools that need that data can easily access it.
So you basically are counting foot traffic in and out of places.
Yep.
But this data is not foot traffic data. This is data for developing the technology which supplies the foot traffic data.
Yeah.
Once it's
It boils down to
all-
data of
yeah.
people walking in and out, but it's to my piece of it, which is different than
Usually your
But-
piece, yeah.
usually my piece of it. It's just trying to get better at understanding how to have a better algorithm. Well, I don't understand the algorithm. That's for the data scientists. They build the algorithm. I make the tools so that they can have access to the data that they need easily.
The sensors, are they building a database to say, oh, someone has
No, we actually have to count that manually. I literally used to mark the in and out of that with the feature that we built, John built. But now we have a third party that will quantitative. So that's what we consider our ground. So that, we compare the ground truth, what those people sent back to us, and I have to figure out a way to import all that data and have it make sense. And we compare that with what the algorithm saw, so that's how we know what accuracy is.
All of that input is time stamp also, so you can capture
Mm-hmm.
the measure based on.
Yep, exactly. Yeah, it seems like such a simple concept, but I mean, the amount of things that, I have such an appreciation for buying a coffee maker and having it work out of the box, because everything is just, the amount of work that goes into making things work is pretty interesting, unfathomable.
Coffee maker's a lot simpler though.
Yeah, coffee makes a lot simpler than our sensor.
You said that there was a situation where, something didn't work and it had to be taken down. So, can you give an example of what happened?
Well, so we kind of had, there's probably better examples than this, but we had a time when we were thinking that we wanted to draw bounding boxes around people, so that the algorithm could kind of track that. So, we basically built that in and didn't do it in a way where it was going to be very usable.
So a bounding box would be, I think you have to explain, it's sort of like a depth picture. I'll bring up the marketing site.
It's like a square around someone.
It's a square around the boundaries of where that person is, but it's always a square. Yeah. It's like the smallest square you can fit around the shape of the person. I think they have some of that old bounding box stuff on the website still.
Or isn't that how they extrapolate shoe size?
Well, the internet's good.
Yeah, you can. It's turned out that the idea was just scrapped. The data scientists are we're just.
Because I'm thinking, so you have the motion sensor, so there's like a.
Yeah,
or
I
maybe
guess.
it's silent or something.
So the this is one technique for, you have to sort of, the number is like the estimation of how likely it thinks that's an actual person or not. So you have to basically take all of these over time and then say, okay, which ones were the same person? And then if the bounding box moves from here to here, then they walked in, and the reverse, they walked out.
So if someone came to serve this dog, oh, that's not that, because that's like a dog.
Supposedly it will not, because it will be a low probability that it's a person because it's a dog.
Yeah, but we've abandoned this approach, and now it's mostly deep learning. So
Yeah.
Deep learning is looking at
I don't like
shoulders.
this is making mistakes. It's like on the animation right on the homepage.
It's right on our
It's
marketing site.
out of date and it's making mistakes.
It's so out of date. Yeah.
Anyway.
So I work with people that just know a lot about databases. So Gus and I built the accuracy reporting structure, so we didn't do it wrong and have to redo it. But if I had built it, I would have not thought forward to all the things that Gus had thought out, basically with fingerprints and so one model can have a fingerprint based on what its foreign keys are. You guys have done much of that, and I was like, this is a whole new world to me. And I just wouldn't have been able to think about that. But because we had built it very well, we can kind of like easily feed this reporting structure into AWS and get information back. So database design is like an art, I think, and it just is experience and probably running into problems and realizing like a better way to do it. But you can't just build something and not think it out. Like it really helps to have a plan for building.
And the database.
It is. It's pretty fun.
So I've turned off the YouTube stream because I don't know how much of this is trade secrets or not. But here's what she's talking. This is the actual diagram that we worked on. So there's a whole lot of algorithm accuracy, installation. There's a lot of really confusing and similar things.
So what this can do is instead of just always having an accuracy report with like all this data, like accuracy numbers, with all these separate things, you can make the reporting structure more efficient. So through this, you can see accuracy report result has annotation fingerprint. Basically, with those fingerprints, you can take a fingerprint and see if anything attached by a foreign key matches that fingerprint and pull those in. And now you don't have to make that row again. And now you don't have to feed that into the accuracy report. You can just pull in previous data. So it's like incredibly efficient and good, and rightly so, because AWS is really expensive. Like the reports that we're sending them cost money. So this is saving us a lot of money by building something with fingerprints.
So I had a driver sign in using our fingerprints. So that's kind of like what you're doing here.
The concept is so each fingerprint has a piece of information, which is model tag, reports tag, architecture. So different pieces make up the fingerprint. Oh, and actually what we're talking about here is a MD5 hash.
Yeah.
Which is like a coded string.
Max is going to get into hashing and the science of that for passwords and things. So you probably haven't heard much about hashing, but it's a way to sort of compress and jumble up a bunch of data to get one sort of continuous thing that's unique per input. When you input something unique, you get something out unique.
Like you can MD5 hash your name, and that'll always be the same fingerprint. But if you put your name plus purple or your name plus gray, it'll be something else. So,
we're calling it. It's like a fingerprint of some data. So it's
not like a fingerprint.
Yeah, it's a unique. No. Yeah. No.
Right. Yeah.
Just for clarity, if you're used to the crow's foot, these are going to be a little confusing because the diamonds here are like where it would be the 3 branches, and this is like the 2 bars. So exactly one and 0 are many. So it's a weird notation compared to what we've been looking at, but yes.
I look at this every day. This is always pulled up. Like
it's useful to have it for the long term.
Yeah, I've been using this database forever, and I still have to look at this to figure out how to get from one piece to another. But I mean, that's why good schemas and good planning are key. Otherwise, my every day would be awful.
Have you ever had a problem? Because I know your database continues to fill up. That puts more load on the servers. So, like, how does one, when you monitors that, like, place that load where it's like, oh, we have this server, but things are getting confusing.
Yeah, actually, we're at the point where we need to install some software like Scout. It's like a monitoring software, and we don't have it yet, but we need it because we are realizing that there's pieces that are slow. And we could try to manually go in and I guess test every query, but that would just be insane because our code base is pretty big. So there's software that will monitor what queries are being hit the most and like how long are they taking. So we'll hopefully be able to flag like our pain points and make those way more efficient.
So you have speed reports or also
just visually right now. Yeah. So we know we need tools.
Sorry. Do you run all your stuff on in-house servers or do you use like AWS? Or?
AWS.
Nice.
We used to have in-house servers, but we maxed that out pretty fast.
Yeah, and we send these reports to like a batch of like what 40 or 80 servers at a time, so it fans out to like many servers, and they go through thousands of captures to test the algorithms. Yeah. All right. Any other questions? Thank you again. Really,
You're welcome.
thank you.
Yeah, nice to talk to you guys. Take care. Have a nice day, Lisa.
See you. All right. That was fun. I'm glad she came. Yeah. Chris is great. She's, she's not a morning person like me. So we sometimes work like the 10:30 to 7 shift or something like that. Sometimes we go in earlier, but sometimes it's like we're not there, the first people in the office often. But nothing wrong with that. That's another nice thing about a small company and a company with laptops is it's like, and everything's on the internet. It's running anyway. You don't have to be there at a certain time unless you have a meeting. So that's pretty cool. And yeah, there's they're doing a lot of really interesting things with, it's kind of amazing how like much of the product and like how like the quality of what we're selling people is so much impacted by how well we do the accuracy, like developing it and coming up with like ways to organize all of that data. Because when you come down to it, building something like that, it's like one of the harder things is not just understanding all the math that goes into the algorithms, but it's like having the systems in place and having all of that working on a day-to-day basis in order to sort of like test against a large amount of data and collect a large amount of data. I mean, we need to have people basically verifying that things are actually accurate, ground truth, compare this to what the sensor says, and that amounts to a huge amount of work. So it's organizing all of that is a huge task. And it's pretty cool that Charissa has sort of jumped right in and done that much with it in the past couple of years. And I think she's sort of branching out to not just developing algorithm stuff, but she's sort of been the go-to person and sort of people have been throwing work at her that about, all about developing those tools for a long time. So it's been a lot of cool stuff. Anyway, so I think today we're going to talk more about ORMs. We're going to do a little more updates and add some nice features to our the chat app. And I think for the end of class, if does anyone write up from data today, or do you think we should defer that, just do the chat example more? Okay. I think why don't we say like we can reserve the last half hour if anybody wants to, or reach out to me on Slack anytime you want. Like if you want to do it one-on-one, I'm not sure like what the best format for doing this is. So just let me know like what you think. And we'll do quite a bit more ORM stuff today. I forgot to print out my notes, so let me quickly like go to my cheat sheet here and copy some of this in progress code over here. And then you might see me looking at it like cheating. But for right now, I'm gonna revert all of this back to okay. So these are the, I never checked this in, but these are the models we were working on yesterday. And I pasted those right into Slack, so I'll get rid of this. And I don't think there's any new changes since yesterday. So I'll just pull and push to make sure. Get rid of this, save. I've been messing around with this SQL here a little bit. Okay, so can everybody get back into VS Code, and let me get the font size all set up. This is like every day I go in the morning and I'm not plugged in. Yeah, it's gigantic because I'm not plugged into a TV or anything. So I have to bring it way down, and then in the evening I have to put it on the TV and then bump it up. Just let them in. Cool. All right. So is this a good size for everyone? Okay. Is it working? Good. Nice. Cheers. That's good. Okay, so let's everyone get into VS Code. We want to be in the chat room ORM folder. So if you're not, you do CD gust cost, and you can type it right away, but you can do CD gust cost, enter, and then CD chat room, and then see it doesn't complete all the way to the end because there's 2 folders now that start with chat room dash. So it's only going to complete what it knows, there's no other options for. So you have to type the O and then hit tab again, and that'll complete this time. So if everyone's in this folder, the next thing to do is check that we have Docker. And I have it running, and I have a work thing. So I'm just going to quit this one so that we will have just the one. And everyone should see something like this. So Alice sent me some scripts that are actually going to be pretty handy for this. Let's grab these and I can show you. Actually, what I'm going to do is just drop these right in this channel. So, so we're getting VS Code set up, and we're going to be in the chat room ORM folder today. We got to run Docker PS to make sure our Docker's running. If it's not running, let's not even bother to find that long thing, because Alice made some what are called shell scripts, and these are like nice ways to sort of save complicated shell commands in a file somewhere. So you don't need, it's just like you'd have a JavaScript program or any language program. These are programs to run from the shell, and this makes it easy to like have some big set of commands that you're doing all at once, and not have to remember them or look them up and paste them in every time you're doing them. So what I'm going to do is I'm actually going to copy this whole folder right into my sandbox folder, just because might as well. And that is here, sandbox. Oh, it's in, where is it? Documents? Into my, yeah, but I want to copy it into my sandbox folder, which is here. So I'm just going to drag it right into here. If we go back to VS Code, you can see it shows up right away, this new folder, Postgres Docker scripts. And what I'll do right away is commit this, add shell scripts for Postgres Docker. Thanks. What's your GitHub handle? Sorry.
WEAK.
Right.
Yeah.
I will do a shout out because that's classy to attribute them. And okay, so if we go cd ... out of there and then into Postgres Docker scripts, and I do ls, we have join Postgres container, start Postgres container, and stop Postgres container. Well, I already have Postgres running because I can do Docker ps, and I'm just going to do // and then say stop and tab. And this is, so this .sh is a special extension. It's called, it stands for shell. So this is like a program like JavaScript or something, but instead of running in a browser or node, which is where you run JavaScript, this runs directly in your terminal, in your shell. So you invoke it by just dot means this very folder, which I'm already in, and / is the folder, and then the name of the file. If you just hit enter and you put that in as your only text, it'll run what's in that file. So, you know, it's probably a good idea to look at what's in the files before you run unknown files on your computer. I trust Alice didn't give me a virus here, but okay. But so this, if we look in this file, this is going to have it's going to run two things. And these are things, in this case, you could just copy right out of this script and paste them into the shell one at a time, and it would do the same exact thing. So a shell file is really just a collection of a whole list of things that you would normally type into the shell or paste into the shell if you didn't have it, but they're just a way to organize and do it all at once. So if I paste both of these, it's going to be fine. Although this is looking for name. How does it know what name is? Oh, because it's sourced this special vars. This is a nice technique. So if you want to basically import and run one script at the beginning of every other script, you do this, which will basically like execute everything in it in one line, and then you can continue. And if we look in vars, it's setting an environment variable in the shell. So name is going to be PG, and when we run docker stop $name, it's going to know what that is. And everywhere else, if you look in the rest of these scripts, name is used likewise, and we source this vars. So this is a nice way to not have to copy the name of the container everywhere. And then if you wanted to change the name of your container, you'd have to update it in 3 or 4 different places. This is a very, right. So this basically is a variable to abstract away what the name you want to call your container. And home is it's a variable, but this is one that's built into the environment when you first start your terminal. So this one is not in the script because it's built in. And if you remember, this is our long command. This is the same command. It's been split up with backslashes, so you can do many lines. And this is a nice, neat way of formatting it with these backslashes. But that $home there is from the command originally, and this is a built-in variable. But it's a variable just like name is. It's the same kind of thing. We just don't have to set it. It's always going to be your home directory by default. So that's how it starts. This is this is basically that long command in a file, and you don't have to remember it because it's saved now in your repository. And then the join is the last one. This is that exec-it. Again, we've used the name variable from the same place, from that same common script, and we're running bin bash. And this is the same thing we were running all of these things by hand, but this is a great idea. Thank you for doing this, Alice. I mean, this is a sound thing. If you're going to work on a project over the long term, it's really nice to have, you know, an organized set of tools like this that do the things that you're going to be doing many times. And it would be really good. Maybe my contribution, I'll add a README to this folder that will describe what these scripts are and what they do. And then in theory, you could just hand this to any developer who knows what shell scripts are and just say, check out the README, you run this one to do this, you run this one to do this. You have to have Docker installed. And that's all you'd really need to do. We need to say install Docker pull Postgres, because we need the Postgres image, and then use these scripts, and that's it. So that's very cool. So anyway, we've done, well, I pasted these, and if we do /stop Postgres container, we can do that as much as we want, but it's going to error every time because we've already stopped it. And if we do Docker PS, we can see that it's stopped. Now, if we do /start Postgres container, that's all we have to do. So no more pasting the giant command. If we do Docker PS, we see that it started. And then if we do /join, this is going to log into our, this is going to shell into our Postgres. So this uses the name that we have set common in the common area, and it does the exec command. So we don't need to remember any of those anymore. And that's terrific. But for today, again, we're going to be, oh, I'm not in Postgres, I'm in Docker, so I do exit. Okay, so for today, we're not going to be using the container directly. We just have to have it running so that our ORM can connect to it, and so that we can continue working on our JavaScript application, which is going to use the database. So the database has to run so that the application can connect to it, but we don't need to go directly modify anything in the database. Okay, so all you need to do, you know, again, the end result of all of that is these are very cool. Let me know, or Alice know, if you want more help using them. I'll try to add a README, but before we get started, you want to be sure that when you do Docker PS, you see that. And that means you're all set. Your database is running. Now we'll do cd ... out of here, and then cd chat room ORM. And once again, I will set up the local tunnel so that everyone can go to that web address. Nobody else has to do this part. Port 8081 and subdomain. Okay. Nobody's taken the URL. This is great. I get it every single day. Okay. So if I do node mon server.js, we're going to start up our server, and it's going to restart every time we make a change. And now if I go to this chat room ORM folder, I can go to this file. Now, every time we restart, because force is true, this is going to delete the whole database and recreate it. And that's unfortunate. I think we should only do that when we need to. So I'm going to set this to false for right now, and then save it. Now it'll restart, but it won't destroy the tables. And unless we have to go back and change the tables, or until we do that, we can leave this as false, and it shouldn't destroy any of our data. And I don't think we'll get into it today, but tomorrow we'll be looking at how to manage the database without having to run this magic thing that deletes and recreates your database every time. We'll talk about database migrations, which is how you manage changing your database while it's actually in production, while you need to keep the data because somebody's using it. You know, if you're altering how it works and you don't want to remove all your data, it can get a little complicated. So we'll talk about database migrations, and then we'll also talk about fixtures, which is basically in development. You want to put some data somewhere that's really easy to just import every time you need. So if you do delete your whole database, you can do that whenever you want, and then you have standard like test data that you can import from somewhere. So we'll talk about setting up a fixture and then migrations for production. But for today, we're still going to just avoid destroying the database as much as possible and then recreate it when we have to. Okay, so to test that all this is working, we should oh boy, is this did I not save anything from? I thought we had 4 more endpoints here, and did I not actually save those? We had this. We had get users, post users, get messages, and post messages. Okay. Well, I'm going to start with the get users and post users and get messages, and then we're actually going to go over a nicer way. The first thing we'll do in the activity is a nicer way to describe these that isn't as promises and then and all of that stuff. We don't really need all of that, so we'll move on to using async await. Did you do a section on promises, async await, anything like that?
Touched on it.
Okay. Yes, but so is promises and so are callbacks. And async await is like an official nice way to do that. It's probably the nicest way there is right now. It's still a little weird, but it looks a lot nicer and it's not nearly as confusing as .then every time and having to remember that. So we're going to convert to use that method, and from now on we're going to use that method. But this is just sort of like if this is demonstrating that Express and our database are both based on promises. So they use the then and the catch, and we can sort of get a shortcut away from having to do that. But this is how it's working under, this is what it's actually doing. It's asynchronous programming that we're going to be continuing to do. Okay, so let's just make sure that if I save this, we can get users at the local tunnel, and then we'll be all set to go. All right, empty array of users. Let's create a user. That's an interesting email, but we've got a user. And if we go back and we get the new user. Okay, so we're up and running. Everything's working. We're saving to the database. Let's do the slides. Does everyone have Docker running, and/or you can just follow along today with the local tunnel? Does everyone have Postman or a way to connect to the local tunnel working?
I got stuff somewhere actually to the point where chat or
Okay. So do you want to, if you want to run your own server locally, and do you want to follow along and develop along? Or let's come back to this when we get the activity, because this is just going to be some little demos first and slides.
so where you are. I'm actually looking at the video that you got there online, and you're at the point where you were in the zip file, the Slack.
Yes.
So what do you do with
You don't need the zip file at all, or to download it or anything. So what I'll do one more time here is commit my changes, latest up to date endpoints. You can just go to the GitHub tab and pull the latest, and you should get that whole folder that was in the zip file is already in my folder. It's called Postgres Docker scripts.
You had that already.
So yeah, we'll keep everything up to date on GitHub, so you shouldn't have to do any downloading of anything other than,
So I'm all caught up.
yes, as long as you have the latest there. And if your server here if you pulled your server and there's no conflicts, or it didn't complain about anything, you're all set.
How would I know that?
If you pull everything at once. So if you pulled and gotten the Docker scripts, yeah. Okay. Okay, so if you want to run the server, once we get to this on your own, you'll have to go to this folder, which is the chat room ORM folder, and do node mon server.js. And if that doesn't work, if that doesn't print out something like this, some yellow, a green, and then a bunch of SQL and nothing else. If it prints out anything else, let me know and we'll get it working. This is here. I'll put this whole line. So that's where the folder is on my computer. I put it in my documents. It might not be in the same place, but you have to be in this subfolder.
It said my app crashed with the sound changes before starting.
Yeah, I got that too.
You have to
I
both.
don't know if I can use it on about this.
Yeah, so you have a whole lot of changes.
You should have always.
Sorry.
So that's, I'm not sure where that Control C. Try running.
Sure.
So you expand your terminal a little bit up so you see the.
Sorry.
It's now. It's not find module index.js because you're not in the cost. You do CD cost. So you do Control C.
Yeah.
Imagine sharing.
In the code.
Right, yeah.
What address?
I mean, we do have an escape. Yeah. Right.
Yep.
The fire marshal.
Do you get the GitHub push pull stuff? Is it all working? No problems. We're good? No?
Did you play PWD? See, and that's cost me. Oh, sorry, CD.
LS, you can do it from here, but instead of CD, do LS. And I'll show you. And first you need CDs.
So now, when you go
Okay, now you should be. It's gonna be CD custom.
Oh, CD has to do.
And then we have to do one more. So LS, anywhere you are, you can see what you have in your folder.
So.
CD to that.
I don't know where I'm.
Okay, now run Docker PS. Check if Docker's working. No Docker. So,
So,
here's a,
he uses it.
Oh.
put it here.
Right.
Remember I did dot slash and then some of those scripts that Alice did? You can do dot slash. Yeah, and then, no, I mean, start, and then just tab. Tab. It'll print out everything you can go to next. So dot slash.
Yep, so I use
This
this.
one. There's, yes, there's no. Now you're in the containing. And you, this is the one that Alice is trying to make. And then we put it in here. POS. And then you can tab again to see what's in there. So you, so this is our just you do start and
Yeah,
tab.
mine's good. Yeah. I don't know. I tried.
Oh, no. It's start, which means that A, because it doesn't know what it is. So we can enter that.
Yeah, not a break all over here.
Okay, I clever. We gotta do CD dot. So we have to go, there's no space, there is a space between. Yep. Slash. So you can do the same.
Oh, so it's trying to load still.
Slash
See
tab.
how you have the access of
Oh,
for school next year. So I think, if you get an extra quick,
dots,
try it again.
just one. And then tab.
I'm sorry, but you got that message.
No, yeah, tab. See, so it tells you what's valid to continue.
I think they're getting errors and you go
Start
it.
it.
Just goes.
Type STA.
So I'll look at the bottom.
Read it. Now it should.
That's a straight to the top of that first.
Oh, now you have to do CD. And then slash is fine. So chapter.
Oh, gotcha.
So you need to go back to the.
Yeah, I think we need to modify your model a little bit.
And tab is always a safe character to hit. Anytime you're trying to type or navigate, it won't ever execute the command. And it'll try to complete it if it can. And then if it can't complete it, it'll complete as much as it can. And if you do it twice, it'll print out all the options you have. And it's waiting to
Just throw up on your code to the.
so I want you to know it's really node mines. Yeah.
Or you can make it like a personal thing or something.
Use example that user model.
Install just fine. You don't use any
Okay, I
package.
see. So we don't have to create that.
Package file here. Create that.
Yeah.
Never had a dog.
So it's gonna be slightly different. So it's, probably the timestamp.
Wow. I can try to make this up. But now there's one of the.
Maybe.
Created.
Once it's done restarting, let me try if that works.
then you add your comma on that last piece.
Okay,
There we go.
let's pick up,
Okay, now try it
let's give it 2 more minutes, get everyone working. This would be nice if we get everyone. Okay,
I have to do it later.
that's fine too, yep.
try it and close the request.
And if anyone wants to do it later and you don't want to have to figure it out just by looking at the video, like ping me on Slack. That's what it's for. It's fine to do it any time of the day. If I'm there, I'll help you out, So don't worry about it.
Yeah, because not that I don't know if it's or not, but we don't know. But when you go to do it, it gives you.
Oh, created that.
To try that, I don't.
So I'm curious to see,
Oh, sorry, it's not on.
I mean, in the videos,
My bad.
like it does the whole, it gets to.
Actually made official database diagram. These are the shapes and shapes, so it might not be
Yeah.
that's your actual name.
Right,
Give that a shot.
yeah, 'cause it's only,
Okay, so.
So it's just.
And when it's those types of-
So I can just change this.
I'm sorry, user ID is. Yep.
Thank you. When they explain it, they're like,
right, it's a very long process.
They're done there. It's running the start script and it's screaming out a hash. Like, middle, after PS prints out nothing.
Interesting.
I'm slightly stunned.
That's a new one.
Yeah.
okay,
I think let's come back to this. Just connect to this server for today. And that's weird. That's
I've never seen that before.
yeah. It prints out, it doesn't print an error. It's like, and Docker PSA has nothing, there's no stop.
Yeah.
Oh, we have RM in the command.
Do we have R?
It is.
Oh, you're right. So it stops.
So it's probably error. So check it out. Start. And not.
Yeah, that part's nice. But I think it's pretty complicated. So. Thank you. Sure enough.
You sure did? There you go. Good to see you.
Oh, yeah, don't worry about those. Those aren't in this file. Your own.
Okay. Here, let me just fix this real quick, if you don't mind. All right, so the link directory on the hard drive is not right.
Yeah, I was copying.
So remember this, oh, okay.
So I
The first part of that command, I created a folder called Docker.
Can you scroll to the top real quick?
The volumes, OCS, and this has, so this has some files, and it doesn't like those files. Somehow, the rest of the database got deleted, and there are only 2 files. That doesn't like it. Okay.
Try adding primary key true in ID.
Container name
does that. But we got rid of the underscore. All right, well, this is, yeah, let's do it. If you can stay after, or let's do it tomorrow, or,
Okay. All right, we got to get the lecture underway. We're going to try to, we've not quite caught everyone up, but we're close.
okay, sounds good.
Alice, the linked Postgres directory wasn't empty, so it was exiting. Now it's working, it's running, but it can't, the server won't connect. It says the connection's being refused. I'm just gonna move forward with this, and we'll try to come back to that and fix that. But okay. All right, so this first section, I'm kind of glad I've included it because it sounds like you did a little bit on promises, callbacks, async await, but not a whole bunch, or it was just a sort of a one-off thing, right? Sequelize, our database ORM, it's a tool that's promise-based. It's sort of like Fetch is a tool that is promise-based. This means that you run some command for the database, and instead of just hitting enter and going to the next line and doing your next command, you have to put your next stuff after it finishes. The things you want to run go in a .then and a function, and you've seen that whole pattern. It's an asynchronous pattern, yes. Instead of always having to do a .then and chain together, once you start a promise chain, you can't do anything ever again outside of it, and you're now inside functions and callbacks for the rest of the time. You can avoid doing that with the async await syntax. It has fewer curly braces and function calls and things like that. Less characters in general. It's usually less confusing to look at. And one of the coolest things about it is you can use if and else and try and catch for exceptions and for conditional stuff, just like you would normally. And it sort of figures out how to sort of make those things behave asynchronously like everything else. So here's an example. This is kind of a lot, but here's the difference, and it may be subtle at first, but with promises, here's maybe something you would do with your database. You'd find by the primary key. This is a function we'll look at. But this is an asynchronous function, of course. So you have to do a .then when you're using promises, and you have to pass this thing a function. And that takes a user argument, and now you have access to the user inside here. And then you have to do your if statement, and you can return this, like even this, if this is an asynchronous function, you can still return this because there's another then down here. So when you return from a promise, it can allow you to then it again. So you don't have to do a then here, you do a then down here. Otherwise, if there's no user, if it can't find the user, we're going to immediately send something back to the client saying the user's not found. And we can just call res.send anytime we want, in any promise, anywhere we want. And that's one of the reasons that you call this thing instead of returning something from your views in Express, is because Express works fine with asynchronous or without asynchronous. It's just you call this whenever you want to send a response, and that's all you have to do. You have to do that once for every possible case, and then you're all set. If we've returned it, we're gonna basically fall through to the next then. And here's where we'd send our success. Now we could, instead of doing this, we could put the send up here, right here, so that there's just send here, and then just a catch at the bottom. But this is just kind of a demonstration that you can return to the next promise, but you need another then. You always need a then. You can never do anything out here once you've started a promise. It all has to be in thens and catches, and this is what the pattern sort of forces you to do. And then at the end, we catch the error with a special dot catch. Works the same as dot then, but this stuff will only run if the promise is rejected, which is sort of like, if an error is thrown, if there's anything that's not a success, it's going to run the dot catch instead of the dot then. If we use async await instead, we can just put a try block here and a catch block here, and we put our res.send here. And then inside the try, so we know we're going to catch any errors inside here. Did we do try catch, or did anyone do this much of this? Okay. Okay, so this was in the fundamentals. There is, try will basically safely run any amount of code you want. And then if that code throws an exception, rather than crashing the program and just exiting, it's going to allow you to do something with the error and then continue. So you can do this try catch just as you would with synchronous code. It looks exactly the same. Here is the await. This is where it comes in. This is why it's called async await. There's actually two keywords. One of them is async, one of them is await. The async keyword has to go in front of a function. And that's the one thing about async await you have to watch out for, is you can't just put await anywhere you want in a script at all. It has to be inside at least one function. So you have to have some kind of function that supports this. And then you put an async in the signature of that function. And we'll do this in a moment in our server. So you'll see what it looks like. But you have to mark that function as async, and then anywhere inside that function, you can avoid using thens and promises and everything by just putting await in front of whatever it is that returns the promise or that is asynchronous. So in this case, the same user.findByPK here, this is the same thing we're running here. But instead of having to put a dot then at the end and having everything go inside functions from here on out, we can put an await in front of it and then assign this whole thing to a variable. And this is a very special keyword in JavaScript, because this is going to pause. This particular function is going to just pause right here. It's going to go back to whatever else asynchronously it wants to do over somewhere else. And then at some point in the future, once this is all done, just like it would call the then function over here, it's going to basically finish assigning, and then continue from this point in this same function. So it's a nice way of basically just doing the same exact thing. The result is the same. You sort of wait and do other things for a while, and then once something is finished, you can come back to it in a special place. But in this case, we don't need to keep doing callbacks or promises with functions inside the promises and functions inside the promises. All we have to do is remember to put the await in front of every function that's asynchronous. And if you don't, you'll get a promise. User will be a promise. And then you'll be like, well, why don't I have any data in my user? It's because it's not a user. You have to await it, or you have to use it like a promise. There's no, this here doesn't return a user, but this whole thing does once you put the await in front of it. Does that make sense? Okay, so and then you can use an if, so we can await this here. We don't have to go into a function or anything. We can say if user at this point, we should have an actual user because we awaited it. If the user is there, we're going to await something else. And this is a function on the, we'll get into these, this will be a model method, a function you can run on the user. And this all, if this is, let's say this is also asynchronous, we await this again in here, and then we res send on the next line, which is just like saying, send then res send inside that function. We just don't have to do that. We can just pretend like it does one and then the other, but meanwhile, it can do other asynchronous things in the background. And this really it looks a little, it's like, why even bother making it asynchronous and do other things in the background? Why not just have this whole thing be synchronous? And that's because if you want to write a server or a web application where you're doing all kinds of different things at once, and you don't want to like block the whole application while it waits for, because this is a big bottleneck with computers, is the computer itself is very fast, but it's waiting for something across the internet or somewhere else on the network to talk back to it. It says, hey, I want some data, and then it has to basically wait until it can download the data. And that's much, much slower than everything the computer itself is just going to run by itself. So this allows the computer to do all kinds of stuff basically at the same time. It can start one of these things, hit and await. It's like, okay, I'm going to wait. It pauses that one, does something else, hits and await there. Okay, I'll pause that one, go somewhere else. And it can do many of these things at the same time. And it's not going to pause every time it has to download or every time it has to do something that takes a long time. And either stop serving requests if it's a server, or freeze if it's a desktop, if it's a web page. Your web page would just freeze because it's waiting for the JavaScript. Asynchronous code won't do that. So that's why you do it. And we're going to start using this pattern with our Express server because I know there's a whole lot here, but does everyone agree this is easier to understand? Okay, good. All right, so our first thing we're going to do is querying with ORMs. So ORM models, each model, when we said had a user model, capital U, and we had a message model, each of those models ends up being linked to one database table. And they can be queried just like the database tables. When you want to read from ORM model, instead of writing some SQL that starts with select some columns from some table, where this and that, you query the data by passing arguments or just running JavaScript functions on that user model, like user.findAll or user.findByPK we saw in the last slide. This is the pattern. It's just more JavaScript functions behind the scenes. This is going to be writing the SQL for you and talking to the database for you and doing all of that. But from the ORM, it's just running a function. To write data, it's the same idea. There's another function, user.create. This will make a user. Instead of having to write some SQL and then send it to the database, this will do it for you. Instead of like just a table with like a list of values that are a bunch of columns, the query is going to return an actual JavaScript array of JavaScript objects. Special objects. They'll have all of the data from the database. They can have more stuff. We'll see. If you do find by PK or just anything that's going to only return one, you only get one object. You might not get an array every time. But it's always JavaScript stuff. It's JavaScript functions that you call when you want to interact with the database, and it's JavaScript arrays and objects, which it gives you back when you read data. Okay, so this is some examples. Now these are still using the promise syntax, but you can see like the comparison. Actually, I should rewrite these as using async await. Let's do that right now. But let's look at them real quick. First, instead of select ID, name, email from users, where ID equals 2, you can use this find by PK function because the ID is what's called the primary key. That's what it means by PK. And all you need to do is pass it the one number. And because primary key is unique, you're always going to get one user back. So you can use that user later on. If we do select ID, comma, name, comma, email from users, where state equals NY, That's very similar to running a function called find all, and then passing it an object that has a where thing, a where key, which is its own object, which has a state key, which has the value that the equals is. So it corresponds. This one starts getting weirder and weirder as the queries get more complicated. And like, I feel like I and a lot of people may have the impression that like, this is a lot nicer. SQL syntax for certain things is a whole lot nicer, and that's true. The problem is once you have the SQL syntax, you need to do things with the data. And programming languages like JavaScript are better for that. So you really need to start converting back and forth. And this, if you sum up all of the effort needed to connect to the database, to pass in your parameters to your SQL strings, watch out for hacking, and then convert what you get back into objects, it starts to be like a wash. It starts to be like, even in this case, where in this case, we want every email that's at gmail.com. We can do select ID name email from users where email like gmail.com or %gmail.com. This one reads great. This one does not. We need to import some special op thing, and then we need to do where object email object op.like in square brackets, and then that is %gmail.com. This is not as nice. So I don't know, I'm probably not supposed to talk about how ORMs are not as good, but again, it starts to balance out once you take into account that you don't have to put this somewhere in your JavaScript and insert the correct parameters, because this would usually be a parameter, and load the data out of and convert it into objects yourself. The ORM is going to do all of those steps for you. Okay, so let's real quick just convert these to async await. It's very simple. We would do, and my syntax highlighting is not, these won't be the right colors, but we do const user equals await. And I'm going to have to, so the first line would be const user equals await this. And the second line would be user whatever. This is actually the ... So await, we actually save a lot of boilerplate and confusing looking stuff. We could say user.name and we get the username. But this is whatever the ... is. We already have the user. We've awaited it. We get it back. Same thing here. Et cetera, et cetera, et cetera. And this is going to be an array because we did find all. So here's the same. This is the same as before. We're using the await pattern. And I won't do this one because it'll take longer than the whole screen. So anyway, yes.
What is ORM and how does it relate to this?
So an ORM is a tool that you can use from JavaScript to connect to SQL and run commands in SQL, tell the SQL database to store data, to fetch data and give it back to you, and work always at the level of JavaScript code and JavaScript objects. So you don't have to switch between, write JavaScript and then write some SQL and convert the data between those two formats. So it does the conversion for you, and it maps the data coming out of SQL, and it actually writes the SQL for you.
So it's like a
It is like a framework, yeah. So a lot of frameworks, I think Max will talk about Sails, which is a JavaScript framework, which it's sort of like Python or Ruby, but in JavaScript it has its own ORM. Django has its own ORM, that's a Python framework. Rails has its own ORM, that's a Ruby framework, but then there are ORMs which are not part of a framework. Maybe they're sort of a library or a toolkit or something. So framework, the word framework kind of usually implies like a complete solution for your whole web app, like Ruby on Rails or something. But yes, in a sense, it's a library, it's a toolkit, it's stuff that's already built in JavaScript that you can use. Okay. So yeah, we're gonna build some more of that into our chat app. Let's look at a couple more things that you can do with ORMs. The first is model methods. When you do user.fetchAll or fetch by PK, or sorry, find all, find by PK, it's going to return JavaScript objects which have one property for every column. So if you do user.name, you'll get the name column of that user row. If you do user.email, you get the email column of that user row. That's out of the box. That's how it works. But these objects can have other things on them which go beyond just the columns that are in the SQL table. So they can have properties on them which are not contained in the database but have like some other computed data. You can say like, we'll add these two columns together and then call that something every time a user in JavaScript has a .email plus name or something, or .email and name. We can try this out, but you can add things to them which are not in the database tables. And that you can even add functions to the users, which allows you to load a user and then say user.run some code, or user. We're going to do one called user.send message. So you can actually, with that user object you just loaded from the database, rather than saying create a message on your own, you can say user.send message, and it will do all of what is necessary to link itself to that message. So it will insert its own key as the foreign key on that message, and it will save that message for you. And you can write a function which will sort of do all of those things for you whenever you want. And these functions, together with the objects you load from the database, or the functions being added to the objects you load from the database, this is called the active record pattern. So this is, I think it was sort of started in earnest by Ruby on Rails. And it means that you load objects from the database, which have data that was loaded from the database, but they can also do things. Here's how you would do something like that. So so this is a SQLized model. I removed a couple of the fields, but let's say here's our user model. We have a name, which is a string, and we have an email, which has it's a string and it's unique, and null is not allowed. So these are just two SQLized model properties. And then you add a function here by doing user, capital U user dot prototype dot whatever you want to name your function. So we'll say we're going to define a new function called send message. And that's a function that takes some text. So you'd call send message, you'd pass it the text of the message. And it's going to go to the database and actually create the message for you. And moreover, it's going to drop its own ID, because this is going to be an actual user row when you run it. It'll drop its own ID as the user ID and the text that you gave it as the text. So this is a way to say, so you don't have to always manually say, I'm going to create a brand new message which has the user I just loaded or whatever. You can load the user and then say user dot send a message, and then the user will do everything else that's needed. So like, let me quickly just type what that would look like. You would say, let's get a little more space here. you would say const user equals await user dot find by PK. Let's imagine there's user number 1, and we await that call, so we have it right here, and then we could do user dot send message hello. And once you have these functions prepared and ready to go, if they're common things that your app is going to have to do and you've represented them like this, you can do this all over the place. You can have users automatically send messages in response to this view or that view or all kinds of places. And all you're going to have to write in order to do that, and this is a complete loading and saving to the database, is these kinds of calls. So you create an object by loading it from the database, and this object is special because you've added this special function to it, and it can send messages. And that's why it's called active record in the pattern, is because it's sort of like each user is a record in the database, but once you load them into JavaScript, they're active. They can actually take actions and do things which are meaningful and easier to understand than, insert into table, insert into table. Once you start doing that a lot, it's really good to package it up into something that is immediately obvious what you're doing, like send message. Yeah.
Could you give an example?
Of this?
Yeah, I mean, you're just trying basically, are you still basically just, so you're just updating the database like you were in SQL, but you're using this method?
So this here is an ORM model. This is calling the function. So remember, I had to write data, instead of insert in SQL, we use a method like user.create, right? So when we're here, we're calling message.create. This is what interacts directly with the database. And here, when we do user.findByPK, this is interacting directly with the database. So it's really this part and this part are the parts that talk directly to the database. But what we've done is added this .send message to every user that we ever load from the database. And this does whatever we want. And in this case, it handles the calling of the message.create and the putting of the user's ID into that message.create. So we don't have to think of it like, a data row that must have a foreign key here and must have data here. We think of it like this is a user, and a user can do things. And one of those things is send a message. You can move up to like a higher level of abstraction while you're coding with this, and you can use these kinds of named actions and named things all over your application. And then when you look at a list of things that you're doing in a certain part of the application, it's obvious what you're trying to do. Okay, so here's another example, like a real world, an example from work. We have the hardware. Hardware units are these little boxes, and I have one. I actually have one with me. Look at this. I'm prepared. So this one is a replacement because my one at home, the fan started squeaking. And we have some of the fans, and some of them after a year or so, they start making noise, which is not good. Anyway, this is a brand new one. It goes like this. It's above the doorway. I'll show it to the video. See, this is the company I work for. We make a device, and it's this device.
Is that custom hardware there, or is it like
this is all? It's custom. There's 3 custom boards, 4 custom boards in there. Too many custom boards.
Nice.
Yeah, there's infrared lasers. There's whole lot of fancy stuff. So this here is a unit, and it has a serial number, right? And in order to actually be able to say, you know, here's this room has 2 doorways, and each one will have one of these units mounted, and it's actually counting like a person would count with a hand counter. We need to have in our database, we need to have data that has a row for each serial number. Each one of these. What? Oh, each one of these has a serial number. Each of those serial numbers has to be stored somewhere in our database. So we know when this one checks in and says, hey, I'm number 7012, we need to know, like, okay, what do we do when this particular unit pings and says, you know, there's traffic? So in order to do that, we have, hang on. Back to here. Okay, in order to do that, we have a table for sensors. We have each serial number as a row, and it has information about this particular piece of hardware. And then we have another table that's doorways, and we say, okay, Tarakai Conference Center door. That would be a row in the doorways table. And so when you say, hey, I want to install this here, and I want to start registering it so that every time this thing registers traffic, it counts it as if people are walking through that doorway. It knows that those two are linked together. In order to do that, you have to do several things. You have to make sure no other units are also linked to that, which you can kind of do with database constraints, but you know, maybe not. You have to make a new record that the installation happened. So we have like sort of a diagnostic history of the device. We have to like adjust some saved numbers so we can report like how many total units there are in this whole building. We want to update some things proactively so that we get some nice statistics and we don't have to calculate them every time. So we have to do like 4 or 5 different things every time you say, this should go on this doorway. No, wait, we're going to put it over here. Some, you know, and rather than having the views where we say, you know, if someone uses an app, there's an app you can use to connect it to the doorway. Or if we go through our admin panel and we connect it to a special doorway. Or if we do any number of other things, they always should have the same 5 or 6 effects. We should always clear out this thing, you know, attach it to here, create a record, and do 1 or 2 more things I'm forgetting. So rather than have each of those places in our API and in our application call that thing, you know, write insert row, delete rows, update rows, and do each of those things, we've made a function called attach to doorway. And this is actually something that we've attached to the sensor model. So when we say sensor.objects.get, this is how you do it in the Python version. It's going to return to you an active record, which is a sensor object, which has all the fields and all the data on that sensor, but it also has a function called attach to doorway. And we call that everywhere. So everywhere we're going to do that, for whatever reason, we say attach to doorway, attach to doorway. And we pass it the serial, or the way that the doorway is linked together, we pass it that argument. And it does all of those actions every time. And rather than have those paste everywhere, or, you know, some other means that's harder to understand, we actually have a function we can run on every one of these objects, which handles all of that for you. So, you know, once you get to having what's called a lot of business logic, and this is like the next slide, it's really good to start putting these kinds of sets of things that happen, you know, and it can be as simple as sending a message like this, but it can get a lot more complicated. And stuff that manages data like this in complex ways, that changes the data in ways, you know, that is not just writing or reading from a single table. You want to make functions with nice names for each of these actions, each of these things you do, and you want to put those functions. Ideally, you want to put them onto your models, and you want to add them to your models or have them somewhere close by your models. Not everybody uses the active record pattern. Sometimes there's a library of functions that the models use. You know, sometimes it's slightly different way of accessing, but you always want that very close to your data models, because you're going to be working with that data from any number of places. And it's really good to have a centralized place, which not only stores the data for, your messages or your sensors or whatever it is, but also stores a whole lot of behavior that those are going to be taking in the system you're building. Hopefully that long.
So that's kind of like the script that we downloaded. You're creating like these functions that you can call back later.
Yeah.
For all of this other data. Like,
Absolutely.
kind of like a shortcut.
Right. So, I mean, it's a very similar sentiment, or it's a similar purpose. We want to encapsulate a whole chunk of stuff that should always happen together,
Right.
and give it a name, and then keep it in one place so that we can use it easily and maintain it easily. Update what that one thing should be. And a lot of the trick comes in like deciding what are those things that are important enough to be official named actions or functions or model methods or whatever we call this.
So you can't do that as easily with SQL.
Well, SQL, so you can write functions in SQL.
Right.
But SQL is a very declarative language. So you don't tend to do step 1, do this, step 2, do this. And a lot of times when you're building an application, you are thinking of step 1, step 2, step 3. That's how businesses think. That's how people think.
Right.
So you often find yourself in that mode. And it's actually very awkward to use SQL statements, which are like, this is some magic declarative wizard spell here. And then like, next we do another one. Like, it's very weird to start thinking like that because you mix them together. And you can, but you absolutely can write functions in SQL. If you are a database administrator or somebody who's like heavily enough into back-end programming and database programming, you absolutely will write functions in SQL because there's the same reason. It's like we're doing so much stuff with SQL language that we want to organize this all together. In this case, we probably won't be doing nearly enough with SQL language to need that. And this has the nice benefit of it being just like any other JavaScript function. And you can use them for this. You can use them for, rendering your UI once we get to that. You can use them for all kinds of things. Okay, so that's sort of, I think I explained a lot better than this slide, but the views, the things that are like hit a view and download some data, the responsibility of that view is to receive a request from a user, to figure out what to do by probably calling other things, and then to answer that request. That's really what you want the view to own. That's what its core responsibility is. And generally, you want your parts of your application to not have much more than one responsibility. It's called a single responsibility principle. It's a very important kind of like theory in programming in general. And views are the responsibility is not for managing your data or messing with your data as much as it is talking to clients, receiving requests from clients, figuring out what to do, and then sending them the data they want. Model.
I'm sorry, when we say views, we're talking about different pages kind of.
Did you do MVC or model view controller? No. Oh, is that coming? I think Max that's next week. All right, well, a view is basically this. So this whole function here, when you do app.posts to here, and then run this function, everything in here, this is a view function. So this is, or a controller function, it depends on who you ask, but it's not a model. It's a view or a controller. It's like somebody is connecting to your server at this address. Here's the request they sent. What should we respond? What's our response? And this is what this function owns. This function is basically, its core concern is determining what to send back. And what side effects, what should happen, what should be saved to the database. And this is why, okay, we're gonna rewrite this in async await, but this is why rather than writing the SQL right into here, or even doing some of these manual create calls, we're gonna want to build functions and build features into our models so that we can say, when you say post messages, we can say, user, something as simple as user.sendMessage. And then the view doesn't have to worry what send message means. It just knows that it's able to call a special function called send message, and that's all it needs to do. Okay. Code that manages data, the model code manages data. That's its responsibility. It saves, it loads, it transforms, it can manipulate. And that code as a whole, when you start adding things to it that are not just fetch and load from SQL, people often call this business logic, because you're building a business program and the business has certain processes and we have encoded them in certain logic, and that's business logic. It's like data, the pure transformations and the things that happen to the data inside the application is the business logic. And this belongs in your models. Ideally, like sometimes it's not going to be there. I think everybody who's worked in the real world has seen views with all kinds of logic in them that really shouldn't be there. And that happens all the time. So you're going to see it, you're probably going to write it. But this is the ideal. It sort of doesn't really belong there. Okay. Should we break now or break at the end of the presentation? We have just one more subject. This one's quick. Validation. Okay, so you can add a thing to your models to every field on your models, to name, to email, to everything. And you can add a setting which says, check that this field has special properties which are not built into the database. It's not a constraint, it's not a unique property, it's not a foreign key exactly. It's something else. It's like this should be only lowercase characters. There's no real good way to say that in the database. Or it should look like an email. There might be a way in some databases, but in general, your application is going to have to check that this is a valid email or something like that. So in order to do this, you can add something to validate the fields on your model. And thanks for bringing this up yesterday. This is actually this is actually a very nice part of this ORM, is that the validation is very easy to define, and they have a lot of nice out-of-the-box features. It's stuff that, the constraints and the actual structure of your data inside SQL can't necessarily guarantee. It's better to guarantee it with database constraints. Like if you want to just write validate and then check that the user exists and check that it matches the foreign key manually, you could do that with validation methods here. But you generally don't want to do that if the database is already going to do it for you. So this, yeah, that's it. There's a whole section on validation, and I put the link there. Like you can say, is an IP address, is a date, is after a certain date, is the number greater than a certain value, is an email, is equals a value, has a substring inside it. So here's an easy way you could say, you can only save emails which end in @gmail.com. You can say one of these, you give it a whole of things which are valid and everything else is invalid. Or not one of these. All of these are invalid, everything else is valid, and so on. You can do all kinds of stuff. You can write a custom function which is going to actually just do whatever you want and return, well, I guess throw an error if it's invalid and do nothing if it's valid. So you can define any kind of validation you want as a function and do it custom right in here. So the documentation lists all of them. Here's just a very trivial example. If we have our user model, we have this email field, and these were all on one line before. But we have type is a string. We have unique, must be unique, and null is not allowed. All of these three are database. These are the database knows what these are, and these are just built in. Like can't be null, has to be unique. These should be in the database. everything else, like if you want to validate that it is an email, you add to a sub-object in here called validate. And in this case, this will check that every time you save a user, it has a valid email. And that's what we want. So this is, you're going to be adding a lot of these to your model for all sorts of stuff. If you have, an email, a field, of course, or if you have a number that has to be positive or between a certain range, that's where that would go. Okay, so I think we're ready for the activity. Homework today, if you want to get a head start on reading about migrations, we're going to get into that tomorrow. And then it is the data diagram and data model. It is all week. That is the assignment. But let's do a break, and then let's do some updates to our chat app. Let's break until 7:40. How about 15 minutes, 10 minutes? 7:35. yeah, it's been fun. It's been it's going to be the longest job I've ever had pretty soon.
Nice.
Yeah. It's yeah, I mean it's more than doubled in size since I started actually. I think we have like 40 people.
Wow.
Yeah, we've just hired some people in Montana and North Asheville.
Gotcha.
Yeah. And you know, we have a lot of remote people. We have an office in San Francisco and one here, and then a little office in New York City. Yeah.
That's cool.
Yep. Yeah, we should do a little like factory tour of the factory some day. What do people say to tomorrow? I'll give them a heads up, see if they're going to be able to do that at like 5:30 right at the start tomorrow. We could just. Oh, darn. Okay, Thursday. What about Thursday? Thursday, 5:30. I'll request a tour at that time.
If your office is right by here, right?
It's right at that end of the building,
Oh,
and
cool.
the factory space is right there.
Oh, really?
Yeah, no, I'm not like on the other side of the wall, but at the end of the hall.
Yeah.
That way. So it's
I didn't
like
know.
it's like opposite corners of the
Yeah.
building. This was available, and it's like we're thinking like we need to get hoverboards or like scooters or something to go back and forth, you know, or have like walkie-talkies or something. Because it is weird. You have to walk for like 2 minutes to go right to the same building. You know? So, yeah.
So is that where all the devices are manufactured?
So that's where final assembly, test, and pack is. So it's light manufacturing. It's not actually surface mounting stuff on boards.
Right, that probably happens like that.
Yeah, that happens at a specialist, not even in America. Yeah, yeah. We actually had we've manufactured some of it in Texas, and the final assembly wasn't here; it was in Texas as well. But yeah, we have also we get all of the board, you know, a board with the pieces soldered to it.
Yeah.
Probably 4 or 5 of those. We have to QA them, calibrate the sensors and sensing devices, you know, the housings and all the fasteners and all that stuff, and then do all of the sort of computer bring up, you know, assembly, testing the whole thing that the thing is within spec and everything, and then packing. Yeah.
That's cool. So how long does it take to get one of those out the door from getting like all the parts in and then going to QA?
I don't know. I hope we're not too much worse than 10 minutes, you know, but I think it's worse than 10 minutes probably, which is like, there's a lot of steps. There's 5 or so steps. And I think on a good day with people who are used to it, are really in the swing of it, like they might be able to start beating that. But yeah, a lot of the steps, you know, take some time because they have to take a bunch of readings and calibrate, you know, the distances are all, you know, so there's a lot of sort of tests. You have to plug it into a test and then wait a little while it runs through a whole bunch of diagnostics. And then after that whole process, we actually have to turn them on and run them through some stress testing of the CPU and everything. So they have to go onto a rack for like at least 24 hours and do that. So that it's really way more than that, but you don't have to actually be there. You know, that's automatic. That's just sit on a rack and do that. Yeah. So
Cool.
yeah. Yeah.
So do you count crowds as well, or is it mostly just traffic in and out?
Yeah, right now it's all stuff at doorways. We can count how many people are in a big, you know, room, like a big cafeteria, but you have to put one on every doorway all around, and sort of it adds and subtracts from a total, you know. And the hard thing about that is that if you get it wrong throughout the whole day, more like 1 or 2 errors, it'll start drifting from the true value, and it won't get corrected until you know it's empty. For example, you could reset it in the middle of the night because like it's closed or something like that. But yeah, we don't actually, you know, I don't know if there is actually a technology that can take a big, huge crowd of people and actually count them all at once. It would need to be very high resolution. And it probably, you know, I don't know if it, in some cases, it wouldn't even be as accurate because like it doesn't have as much, you know, if we got it right, if we get the people right going in and out, then we could be perfect. It's rare in a huge room that we're actually perfect for a whole day, but yeah.
And then businesses use that information to see if their conversion, or I don't know if that's what you call it, but like to see if the traffic to purchase ratio is where it should be, or
Yeah,
like
it's
that.
not really deployed in like retail, like most retail places, there's a whole market for this and they have all kinds of gadgets. They have brake beams, they have CCTV, they have full on camera systems that make heat maps of which stations people stop at
Right.
and like what people of different ages and genders and races like and don't like and like all kinds of crazy stuff. We're like very much like selling this to people who own the space, like a school or a corporate campus that has a whole bunch of meeting rooms or cafeterias, and they want to know how much food to make. And they don't want to be like doing spying on, you know, so it's an anonymous, it's counting, it's just counting. And there's a lot of people, plenty of people who just want to buy that, you know. But I mean, we have a couple, you know, we've talked to a couple of like retail, like people who just are like, hey, you know, this is a pretty nice solution. So they, you know, we have a couple people, we have a bar who like counts people going in and out of the bar so they can help stay within the fire code. That's a pretty cool one. Yeah. It would have to be indoors though, because maybe you could put them at the gates. I don't know.
Like if you got down like
Yeah.
I don't know how they actually do it.
Yeah.
Because we don't always have unless they don't. Yeah, like if they don't like count.
I mean, they have
I don't know, let's do a turnstile, so maybe they're like, you don't count.
they have people standing there though, right? I mean, they're like,
You think somebody's counting?
well, no, but they're making sure. I don't know.
I want that job.
Yeah. Yeah, that's what people do a lot. They'll do studies. They'll pay someone to stand there. I mean, I think my brother worked a summer counting cars with a little clicker, you know. Like, anyway, yeah, we'll do like a tour of that. I hope. I can't totally promise it because I don't run the factory, but I will do my best to get everyone in. Yeah. Let's do Thursday. Let's say Thursday. Okay. So activity, chat room models. Okay, so we have nodemon running. Every time we save this, it's going to restart. It's not going to destroy our database because we have force false here. But if we change the models, we might have to destroy the database. Everyone could go to this local tunnel and get the users or post users if you want to try it from there. And we're ready to go. Okay, so like the first thing is let's go through here and take the these views, these functions here, which are at each endpoint, and let's convert them all to be async and use await because that is a nice convention. So in order to do this, remember I said the one thing about async await is you can't use it out here. You can't say like const whatever equals await user dot find by pk. You can't do that here because we're not in any function. And it has to know at least one function is going to behave as asynchronous. So you have to be inside at least one function, and that function has to have the async keyword somewhere. So if this is like the arrow function, shortcut function syntax. If we were to make another kind of asynchronous function, we would do async function, my function, and this returns, I don't know, promise.resolve. So it would just resolve the promise immediately. But so you put async before the function here. Or if you did const function, you could assign the function to something. My function equals async function and have this be anonymous. But async always goes before either the word function or at least the parentheses here if it's the shortcut, or if it only had one parameter. I'm not sure. Could you do this? Yeah, so if it's just one parameter, you don't need the parentheses strictly, but you always need async before the function or the arguments to that function. In every case, it's always going to be the word async. So this will be, we'll set this back. And maybe like one or two of these we'll write as function, and one or two we'll write as this format, just so you have examples of both. But this one, we just added async right before here. And now we have, this is an asynchronous function. It doesn't change anything about it right away, but it means we can add the await keyword anywhere inside this function we want. And that means we can stop using the .thens and all of this kind of stuff. So we're gonna need to do this eventually, but instead of doing a .then, we can say const users equals await this. And await turns purple, which is pretty cool. And then we can do res.send users. And this is the same, this will have the same effect as the user.findAll.then, and then the function, and then this inside. We're going to say behavior. It'll be asynchronous. This will pause right here while it goes off to the database to ask for some data. While it's downloading that data, it can go run some other part of the program, answer some other requests from other clients maybe. And then once this completes, the database comes back, it downloads the data. This promise will resolve. It's still a promise, type of thing. But in this case, it's going to unlock, it's going to keep running now. So we'll have our users, and then we continue from there. So that's that one's very straightforward. Let's change this one over. Const user equals capital user dot create. Oh, sorry, we want to await first. We got to await it. User dot create, and then inside here we'll do email req body email. I do. Thank you. It would probably just crash if we try to run it and say it has to be an async function. Okay, so that's our new user. So the what this is going to resolve with, and what will eventually be assigned to our user here, is the new user. It's this, the ORM works like this. When you call create, that promise eventually resolves with the object version of the new row you've just added to the database. So we don't need, so we got that. And so look at this, we have a .then here, and we have a .catch. So these are like, this is a sort of a tricky way to like try catch. In this case, we don't need to sort of chain it in callbacks or anything like that. We can just do try, and try this whole thing inside here. So I'll indent that. And then we'll do catch, and catch an error, maybe. And then inside the catch, we'll copy this part, will be what we catch. And if we get past this line, if we await this and it's successful, and we continue, and we don't immediately have an error, in which case we'll go to that catch. We're going to just continue inside the body of this try. So instead of this going in a then or anything, we can just put it next right here. So it's going to create the user, await that the user to be done, assign that, and then send. And if at any point it errors, it's going to catch the error just like any other JavaScript error. So we don't need any of this. And this is our async await function. Okay, and let's make sure that these both still work. We get users, we get our one user. I have another tab with post users. And we'll post this. I think we might get an error here. Email must be unique. So I already made this email. So we just increment that number and we're all good. So everything's working. We get our errors back. We get our results. We can create our user. And if we get the users, we should have 2 now. Okay. Yes. Now, we can also add the other fields on the user at the same time. So we have email here, but users have name, email, state, birthday. Let's make email first, because I feel like that belongs, that's like the unique one that it needs to have. All these are optional. So name, state, birthday, we have to add name, state, birthday. Now, it might be good to be explicit here, but and let's test that this works. If we post a user, whoops, I need to learn to use the tabs. This is the get, this is the post. We can add birthday, and this will be okay. And if this works, email must be unique. Yes, very good. Okay, so we've got our birthday and we've echoed it back. And then when we get, this person has a birthday. So we're successfully saving any of these columns into the database by using the body of the request to send along all of these fields, which we have mapped in our ORM model. Now, if we want to just say send everything, I think it's possible to just say req.body. And then that'll just be like send everything we've got in the request to the user model. And it should work exactly the same. Now I'm going to remember other email too. This works just the same. So we don't really need to list out all of the fields. I'm going to leave this one like this, but then I'll list them out in the message endpoint just so we have some examples of both. Okay. And then also how about this first one? We'll say async function and no arrow here. And this will work the same, but this is just a nice example that you can do function or you can do this sort of arrow function. Now, the only difference is that if you remember all the way back from scope and functions and all of that stuff, when you do it this way, if you use the word this, it means something different. And this is going to actually come up in just a little bit. So there is a small, there is a one or two, and I forget what the other difference is, but there's small differences between these methods. But nothing that is going to affect you if you don't use the word this in that. Okay.
Will it not work with one?
No, it will work with, so it depends on what you're using the word this for. Because the this kind of newer arrow syntax does not create a new containing scope and a new this. It uses the outer containing scope. So the this is going to come from whatever's outside of it. Not from its own scope. So yeah. Now it actually, we'll try it both ways and we'll see if it actually matters in the case where I'm thinking. It might handle it for us, but we'll have to see. Okay, so let's just finish up these endpoints though in the async await style. The next one is get messages. So instead of .find all .then and all of that, we're going to make this async. And then we're going to say const messages equals await message .find all. And then we're going to say res.send messages. And that's the whole thing. And finally, we have a post messages, which isn't even here, but I'll add it. And we're going to copy this whole thing. How about post a new message? Messages. And instead of just request.body,
Being abducted.
what happened? Why did this thing feed back?
Because I connected in Zoom and I'm trying to mute it. Thought it was off.
No, that's down though. Your mic is.
Do I have the stream on? Okay. It's probably echoing. Okay. Cool. Okay, instead of just putting the request.body, which is like every field in request.body in an object, we'll explicitly define that object. And we'll explicitly say message.create. This will be user request.body. User ID is request.body, user ID. These are the two fields from our message model. And the other one is text. So request.body.text. And then we're going to send OK. And the message is that. And we're still going to catch any error and return it. So this now should work. We should be able to get all of our messages. They are empty. We should be able to create a message. And that's working. We should be able to give it a bad user ID and get a good error. Okay, key is not present. And we should be able to get the message we created. Okay, so we have everything working now. This is all with async await style. And we're gonna not use .thens or that anymore. I'm not sure if Max will want to use them for any reason, but it's possible we'll just be doing this from now on. Because everybody kind of prefers this. There might be one or two cases where you'll see promise something with a promise for a special reason. But I think just about everybody who uses this kind of stuff, as soon as this was supported in more modern browsers, everybody switched to using it. So it's very nice. Let's do update server with async await. I don't trust that reload thing, but it probably works fine. Okay. So if everyone wants to pull, if you want the latest. All right, so we have these endpoints, they're working great. Now we can go back to our models and we can start to make these a little bit nicer. So the first thing we probably should do is add some validation. This here, as you saw in the slide, we can add validate. And in here we'll say, is email true? And this is one of the things from the document. It's just built in. You don't have to write your own custom function to determine if it's an email. It has something built in. And we'll just add it this way so that if we save and reload, now because we haven't actually changed the fields, because we're not affecting anything that's in the actual database, we don't need to rebuild the database. We don't need to force true and wipe out the whole database. I think we can just add this, and this is all just happens in JavaScript land. The database is not going to be changed. So we're going to just keep our data, which is great. If we do get users now, that still works. If we post a user, this is going to not work because it's not unique. But if we make like a just email.com, I don't think that's a valid email. So we get an error that says validation is email on email failed. That's exactly what we want. Anything, that's not an email. I think an email has to be something at something. I think that's a valid email. You don't need the .com technically. No, maybe this doesn't work. I think that's a valid email technically, but that'll work. Okay, so an email works.
You need a dot.
I'm not actually sure that you do. It's very, well, so you could do something at com, because com is technically like a valid host name. It's a top level domain, I believe. And I thought an email could be, you could be somebody at com, like, and there, I don't know if there is anybody at com, but the protocol might allow it. I'm not actually sure. Okay. So we've added a validation rule, and that worked very well. Now this here, we could say date can't be greater than, or can't be, greater than something. You can't have like less than 13 or whatever the regulation is. You could set that on the birthday. This here, we probably want to add some validation so that state is only 2 letters and they're capitals maybe. And we could even give it the list of valid states. And so let's look a little bit into how to do this. So model definitions, and then it's in the validation section here. So we have in, not in, contains, max, min. There's a regex. This is a nice little way to do a whole lot of things. There's no is state. So we could do an is in and then have a whole full array which lists out every state code. And I think that would work fine. But let's not worry about so much if it's a valid, one of the 50 states. Let's just make sure it's 2 letters and they're both uppercase. So you can use a regular expression to do this. Has anybody learned about regular expressions? Do you like them? Okay. They're very useful and they're very just ridiculous.
That's a good word.
Yeah, but you're gonna keep running into uses for them, and over the years you'll probably get used to them and even like them for certain things. But it's a whole kind of sub language. Thankfully, almost every programming language uses roughly the same kind of basics for regular expressions. So you don't need to learn a whole new regular expression thing when you switch to a different language. That is very good. Some languages have little special features and extra things, and it's always good to like look up and even do a tester. Did you do a regex tester on the internet to try out regexes? Okay, well you can find on the internet like Python regex tester or JavaScript regex tester, and it will let you actually run real regexes in that language. But most of them all follow the same core rules. And you don't usually need the rules that are outside of those rules for most common things. So that's very good. I don't have to remember, oh, I'm in JavaScript, I need JavaScript regexes now, you know, and for the most part. Okay, so we need to make this a whole full object, which has type is this thing, and we're gonna do validate, and this is, and this can just be a regex literal. And this is gonna say capital A through capital Z, gotta be 2 of them. And we're gonna start it with the start of the string, and we're gonna end it with the end of the string. So there can be nothing but 2 capital A through capital Z, and that's a state code. And it's not case insensitive because it's, well, yeah, make it case insensitive, be nice. And then, you know, if you wanted, you could have your view or some kind of logic convert it to uppercase. So you always save it as uppercase if you want. But let's start with it like this, and let's try this out. So state, not a state code. Validation is on state failed. That's a fun message. So it means validation is, because we call this thing is, and then it's a regex. That's not a very good message, but at least it validated it. So we can say New York, email must be unique. Well, of course. But once we've done that, it's going to work fine. And if we do anything that's 2 letters, ZZ, it'll be fine. Letter, it's going to say my internet connection is unstable. Validation is on state failed. That's a great message. Okay, so these are some nice little validators we have. The birthday one, let's I guess let's try out what we can do with this. So is after and is before are for dates. So we could say, you know, a reasonable birthday maybe. So we'll open this one up again. We do type is this, make our object, and then validate. We say, we're going to need some lines for this probably. Is after, and this is, how about 1900? Somebody could be 119 years old. And then is before, let's say anyone born, is anyone, nobody's born in the new millennium here, is there? Is anyone 18 or? Yes. Not. No. Okay. So nobody allowed in the new millennium, millennials or whatever you call them. Yeah. Oh, Will. Sorry, Will, if you're there. You know, eventually we'll loosen the rules and you'll be able to use this app, but for right now, you're banned. Okay, so yeah, is after is before, and this should work in the same way. I don't think anybody's going to be surprised here if we do 1890. And something for, it's not going to work because validation is after on birthday failed. And if we do 2015, validation is before failed. And this person just squeaked in and they're all good. So that's cool, right? Those validators are terrific. Very convenient.
how do you deal with that, like with European dates? They don't usually.
This is not anything. This is like, as long as you're on the, whatever this whole calendar is, Gregorian calendar, whatever is we are in 2019, as long as it's that date and it matches, this is not native to any country this way, year-month-day.
Yeah, but like the format, how did we get to that format? We put that in at some point.
It just knows that when you're doing dashes and it has 4 digits to start with like this, and it looks like this, that it's what's called ISO 8601 format for dates. It's like an international, ISO is International Standard Organization.
So, Linda asked a question.
Oh.
Actually, it's a really good question.
Yeah, interesting. Okay, so yes, that is a really good question. So if your app had people had to be 18 or 13 or whatever the rule is, you could deploy it today, but in 10 years, your dates would be out of date. So that's a very good question. Let's figure out how to do this. So we haven't even started using, but we have Moment here. And Moment is really good at dates and things. And we could very easily figure this out by, let's go to the node. I quit the server and I'm just going to go into node so we can try a couple of things and then figure out what to do. So we open up node and we say const moment, or what do we do? Const moment equals require moment. And then we can do moment as a function, and this is going to give us now. It's a whole big object and whatever, but this is right now. So every time you call it, you're going to get the current moment. We can do moment like this dot format, and then format it as all kinds of things. One of which is year, month, day, I believe. And that's today. So that's a nice way we could always insert today. We could say moment dot subtract, I think 18 years. And that's 18 years ago. It's a very nice library to use. You have to watch out because every time you call something like this, it actually mutates the moment. So remember all that stuff about mutating your arguments and mutating your data. Moment will get you because you'll say, oh, I want to know what's 18 years ago, and you'll change the data, and then it'll be different. So that's the one thing to deal with. Yeah. Yeah, so watch, I'll demonstrate. We do const, won't even help that it's a const, but we'll call it x equals moment. Okay, and we have x dot format. This is a shortcut for the date. Oh, the date in your local format, nice. So you can even show it to users in whatever format their browser is in, which is pretty cool. So we have that, okay, x is today. We can do x dot subtract 1 years dot format L, right? And we get 2018. Well, let's see what happens if we call this again. It's now permanently 2018. So the only way to stop that from happening every time you do something like that, you have to remember when you're using moment to moment again and pass it your last moment. You have to do this to start every time you want to manipulate moment. It's a bad idea to take a variable from somewhere and just dot subtract on it. You always want to wrap it in a moment like this, because what this will do is print out 2017, but then when we go back to X, it hasn't changed. So that's a nice little tidbit. Watch out for that if you're ever using a moment. Yeah, it's one of those things you just have to learn by getting burned enough times, or just maybe flashcards or something. Don't subtract don't store a moment and then do things with it. Always wrap in a fresh moment when you do things to it. Always. Okay. But that's so this is pretty close to, because it's a brand new moment, we just call moment with empty parentheses. That'll be now. And then if we subtract 1 year or whatever, so we can subtract 18 years and we can format as year, month, day. And that's going to be 18 years ago. So we can copy this whole thing. That's what we want it to end up as. And we can say is before that. And we can say is after, let's say is after subtract 118 years. So anyone who's older than 118 years old can't use it either. Yeah, age 18 to 118 is what the box says.
Not a day more.
Yeah. Anyway, so that's how we can do this. So the one thing that this will, whoops, 118. Okay. The one thing to watch out for this, though, is when does it run this moment thing? Because this is the only time that it's going to actually get now and then convert it to whatever. Well, it only runs this every time that you start the server. So if you start this server up today and you leave it running and it's a really good server and it never crashes, and you leave it running for 10 years, it's still going to have the same problem. Because this will have been evaluated at the time it set up your model, which was right when it started up. Okay. Right. So that's something of an issue, and the way to get around that is we have to define a totally custom function and do a fresh moment every time we validate. So why not? Let's do that right now. This is actually a great example. Thanks, Linda. This is terrific. So you do a custom validator by basically just having and that's the function. What? I don't know. Is this gonna work? Okay, let's try it out. Is old enough. And I guess, oh, they're doing this shortcut where you don't have to give it the name. You just put it right here. This is the same as is old enough colon function. I don't like that that's too new for me. I don't like it. Anyway, we're gonna do it the way that's familiar to me and not weird. But if you want to get fancy, you can delete both of those, I guess. Ugh, that's weird. Okay, so we can do if moment value dot subtract 18. Sorry. So this is going to be the value people pass in. So this is going to be not today. This is going to be the birthday they entered, right? So we need to add 18 years to this and then check if it's greater than now, right? So moment pass it the value dot add 18 years, and then we can just do greater than moment, which is now. And every time we run this function, it's going to do the same line, and it's going to run the same moment, and it's going to get the latest now. So it'll be the now at the time we're validating, which is what we want. And if that's true, we're going to, I think this thing says just throw new error. New error. Get out of here. You damn millennial. All right, I won't be, it's generally a bad idea to make your code mean. So I'm gonna say, please be older before using the app. All right, so we can get rid of is before. Yep, and that's is old enough. That's a custom one. So let's see how this works. Four. We lost our local tunnel because I closed it to go into Node. All right, here we go. Okay, so we need somebody who's not old enough. 2003. Man, time flies. All right, please be older before using the app. So we get our message back. And if the person is now older, or the time is in the future, this will both work and they're fine. So we can do the same thing, of course, with is not too old. I don't know what you ask someone who's already too old. They can't get younger. Say, please be younger. Please be younger. So we should get the same thing. Add 118 here, and it's greater than the no, this is less than. So if we add 118 and they're still less than now, that means they're older than 118. Okay, so we can do 1899. Please be younger. Okay, so that's a cool example. And I think that's all we'll do for validation. And we don't have a whole lot of time left today. So I think I want to demonstrate one more thing, which is adding a model method. Just like we showed the example, this model method, which will allow us to say user.send a message. And this is not the greatest example of why you would do this, because it's a very simple, just one insert that we're going to be wrapping in this function, but it's just a way of showing how it will work. So once we've defined our user model here, the way that we add functions to it is we say, okay, user model's here. We're going to say user.prototype. I'm not sure if anybody talked about JavaScript prototypes and everything, but they're sort of like one of the ways that JavaScript works is that each object has a prototype, which has its functions and its methods and its things on the prototype. And it uses this word everywhere, prototype. It's, instead of like classes being built in from the start, JavaScript used prototypes for inheriting things. You probably heard of classes in other languages. JavaScript now has classes, which are, who knows, there's some version of prototype stuff. I never use classes. I really never use prototypes either. But in this case, this is how you add functions to the user model. And this is very JavaScript native. This is like, I think it's going to be doing new user, because that's why you would add something to the prototype, because when you add something to the prototype, every time you do new that thing, the object you get back has whatever you've added to its prototype. And that's exactly what we're going to do here. We're going to add a function to the prototype of user so that every user we load from the database has special functions and things we can run on it. So this will be send message. You just call it whatever you want the function to be. And this is a function. This takes text, and we're going to return. We can just return right off the bat message.create. And message.create is going to have the fields on the message we're trying to create. Now, this is where we can use one nice little thing about this is we already are on the prototype of a user. So we've already loaded a user from the database, and we already know what user ID this message should have, because it's going to be this user. This user is the one sending the message. So we're going to load the ID from this user and do this with user ID is going to be this.id, and text is going to be text, what we've sent as the text. So this here is going to return message.create. Now notice this is not an async function, and this doesn't await anything. That's fine to do it like this. If you're not going to do anything with the message later, then this is fine. You could always make this an async function, and you can return await. So, and you can also say const whatever equals await and do more things, and then return it later. So you could do any combination of that. I think I'm going to leave it like this, return await message. So this is an async function, and it's going to return the message once it's come back. So but this whole thing has to be an async function because we're using await. All right.
What is that?
Await, it's the same as when we're using.
I got the await, async and await.
Yeah.
Why didn't you just add that? I kind of lost. What were we doing?
Because you can. I mean, let's not add it first.
No, not that part. Just the whole user.prototype.7.
Oh, well,
so we're just adding.
We're adding a function that you can call in any user, and I'll show you what it looks like right now. No, to send a message.
Oh, send a message. Okay.
So as that user, so this will create a message row, so message data with the user ID being the user who called send message. So for post messages, let's just imagine we wanted it to do it with this new method, and it's actually like, a little bit, it's kind of silly to do it like this because we're going to be doing two calls rather than letting the database tell us the user doesn't exist. We're going to like load the user and then send message as the user. So it's a little more complicated when you want something that's not just write a single row of single data. You'd want to be able to load a user, check that the user exists, and take actions, do things that are not even in a database, maybe send a text message or something based on that user, and you can put all that in these functions. So we do const user equals await, user dot fetch by pk, and we'll pass that request body user ID. And then instead of message.create here, we're going to say await user.send message with request body text. So does that make sense? We are awaiting, fetching the user first. And because we defined this send message on this prototype of the model, every user we load from the database has a send message function. It has a name, it has an email, it has all the data fields, but now it also has a function, and it can do things. It can send the message. Let's check that this works. So this will be post messages, and this is still not going to work. But we have an interesting new error message here because we don't end up with a user at all. If we console.log user and there is no user, it's going to be null and it doesn't have a send message. And we're going to get down here. We don't have any good error because we're not using our ORM to just try to insert and return the errors directly from the database. We loaded a user, it says happily, here's nothing matches. It doesn't throw an error. We have to check for that error. So we get error and we get no console.log. Why don't we get a log? Post messages, we don't get a log. Well, this is a lovely end to the lecture. Is an error, but it's related to, yes. Tune in tomorrow. We'll figure out why. But anyway, the error is now totally broken and we've done something bad. But if we do user ID 3, we should get the success. No, we don't. Await user fetch by PK request body user ID. Await user send message. Okay. Let me take a cheat look at my function here and just see what I'm doing wrong. Prototype send message function here. Turn that. I called a function called fetch by PK, and that doesn't exist. So it's going to say you don't have this right PK, and then the error gets swallowed up. I got to figure out how to pass these errors back in a better way because you're so used to getting these really nice errors right from the database, you know, when you do it the other way. And we're going to have to do more complicated things. So we need, you know, a way to get to propagate that that error. Yeah. Okay, so it works, and you know our errors are just broken, but that is a cliffhanger. We'll pick that up tomorrow. So we don't really have any time for data models, but the homework is to work on your data models and get the diagrams and decide on all of the data you're going to work on. At least your first guess at that. You know, you don't have to get it right. You don't have to like completely nail it. You're going to change it as you realize things. So don't worry about it, but you know, come up with your first, the version. Some people are pretty close, but, and then we're going to build out all the validation and all of this model stuff we need. So that's homework. Good night. I'm going to check into GitHub right now.
Thank you, Gus.
Yep. Have a good evening.
You too. Thank you for all the work.
Yeah, you too. I mean, everybody is doing a ton of work in these things. So, you know.
Not really. I'm here during the week.
I mean, it's a lot of work to show up for 12 hours a week and like stay awake in the evening, isn't it?
Yeah.
Like, it's pretty impressive. Everyone is actually paying attention pretty much. It's amazing. You know?
Well, I feel bad drifting away. It's like looking out the window when you're here the whole time.
Yeah, but I'm here for 2 weeks this time. You're here for 20 something. So.
You went to like all that stuff too.
Yeah. You know, it's you know, don't worry about it. Technically, I am getting paid. I have to submit hours to actually get paid, but I think I'm going to do that. So I get paid for it. Right? And,
So my GitHub thing is like we can't push your pull or whatever because you've got merge conflicts.
okay,
So can I just like
you can
trash my
trash the whole folder.
the whole thing back down?
Absolutely.
Okay.
Feel free to try that. You can try discarding all your changes and like in the same repo, but the sort of the eject lever is just delete the whole folder, clone it again, and then you should have the latest everything. Yeah.
Okay. Very cool.
Yep.
I've been fighting with it, and I'm like, you know what? I don't like you anymore.
Yeah.
I want you gone. Yeah.
That's the point of having it on GitHub is you don't have to worry about your local copy that much. All right, stream, bye stream, so long.